Welcome to this video on what's expected from you in the examination for COMP1639. In previous years, there was both coursework and examination which covered exactly the same subject areas. This meant double the work, both for students and the staff, and without any extra benefit. Students have too little time when completing several courseworks at once to gain as many marks as possible in each. It was therefore decided that it was in the best interest of the students to move to examination only. This means that students can then concentrate on coursework and then concentrate on the exams, and that should improve marks. Please note that a mock examination and marking scheme will be made available shortly before the exam. The format of this mock exam, 7 compulsory questions, will be the same as the actual exam. However, the scenario and the questions will of course be different. So let's start with the scenario. The examination starts with that scenario, which will normally be given to students about a week in advance. Students who work through this scenario alongside their exam notes and the mock exam should be well prepared for the examination itself. So, what are the questions? Well, question 1, the students should know what's expected in an ERD. For example, the names of primary keys and foreign keys should match. There should not be any duplication of data, and so on. These general principles underline all methods of database design, whether you're going via the normalization route or the object-oriented route. Question 2 is a little more specific. It asks you what should be shown in a conceptual ERD. For example, primary keys should be underlined. The cardinality of the relationships should be shown, although you can have many-to-manys. Subclasses, if required, should be shown, and so on. The emphasis here is not on a detailed understanding of the scenario, but rather the creation of an industry-standard diagram. A student who is not familiar with the topic of the scenario will not be penalised for making any reasonable assumptions. So what is a reasonable assumption? Well, if the scenario were asking about, say, astronomy, and you had no idea how many planets there were in the solar system, if you assumed there were 3 planets, that would be fine. That wouldn't change the basic principle of your database design. However, if you assumed that everybody using your work was a Martian who typed with their toes, that would be unreasonable. So now we move on to question 3, which asks you to create a physical ERD based upon the design created in question 2. What's being assessed here is the knowledge of how to turn a conceptual ERD into a physical one. This means that students are not penalised if their answer to question 2 has flaws. For example, the marking scheme awards marks for the correct resolution of subclasses, the correct placement and naming of foreign keys, the identification of suitable data types for each field, and so on. In the past, some students have purposefully denormalised their design in order to make the next question much easier. A design which simply simplifies the SQL and is denormalised will be penalised in both this question and in question 4, as well as indirectly in question 7, which I'll come on to at the time. Question 4 acknowledges the fact that you will not have computers available in the exam, and therefore silly mistakes, such as misspelling a word or using a comma at the end of a command instead of a semicolon, will not be penalised. Students should show both an appreciation of the syntax of SQL. For example, a select command would be select from, where, and so on, as well as the logic of the command or commands being created. Imagine this as the first draft of a query before testing it in the DBMS itself. Question 5 examines the knowledge students have of some of the more technical aspects of database implementation. For example, the types of views and how they could be implemented, or the types of indexes and how they are implemented might be asked. Students should show both a practical and theoretical understanding of these areas of the syllabus. Question 6 covers the theory of good database design and implementation. You may be asked questions about ACID, locking, concurrency, and so on. You'll be expected to demonstrate a knowledge of what these terms mean and how they can be used in the case study. In other words, how would they get implemented in real life, which is what you will need when you go out to work. And finally, question 7 covers the relational algebra and will require you to turn your answer to question 4 into both a relational algebra expression and/or a logic tree. Students who purposefully denormalize their database design to make question 4 easier will also lose marks here indirectly because they will not be able to show a full range of relational algebra tools. I hope this clarifies the situation, and I look forward to you all getting 100%.